Good morning, my name is Camilo Alexander Hernandez. I am a student of 8th semester of System Engineer. Today I am going to speak about the core probabilistic simulation applied to the calculation of electrical machines for the simulation course directed by the teacher Caroline Moncada. The topic is very interesting, so let's get started. I am going to speak about the structure of the article. It's basic on the APA standard and information is basic on the database university. The title is Probabilistic Simulation Applied to the Calculations of Electrical Machines by Camilo Alexander Hernandez. As introduction, we have that the stochastic calculus arranged mathematics oriented to the analysis of random variables that depend on a parameter or argument and varies at time basis. These variables have their own probability distributions. We have to speak about the deterministic model, can be considered a mathematical model. On the other hand, we have to speak about the determined aspects such as uncertainty of the vital importance for the modeling of mechanical system. It is the node. We have to speak about the cumulative distributions of the system. It is the results of the investigations. About distribution, in each case is the normal distribution of the gear torsion. The conclusions and the reference. In this case, we are explaining the type well done in the article. Concept. An electrical machine is a device that have the function of converting any type of energy into electrical energy. These machines can be divided in three parts that are generators, motors, and transformers. Now let us know the concept of stochastic calculus and its important in this project. The stochastic calculus is a branch of mathematics oriented to the analysis of random variables that depend on other parameters or arguments, and there is a time passes, the variables have their own probability distribution. This allows to improve the quality of prediction. Now we are going to talk about some examples of stochastic calculus. The analysis on the climate and the index of the stock market are common examples for the stochastic simulation. For this, there are methods that allow to simulate the behavior of a set of variables in a system. In this article, refers to the Monte Carlo model and chaos polynomial with which it sought to simulate the behavior of a gear of a machine electric. We will talk about the Monte Carlo method and chaos polynomial which were used in this article. The Monte Carlo simulation is a method focused on solving mathematical problems through a statistical model that consists of generating possible scenarios resulting from a series of initial data. This method provides approximate solutions to a great variety of mathematical problems, making it possible to carry out experiments with samples of pseudo-random numbers on a computer. Now, the chaos polynomial decompositions aim to represent uncertain data as polynomial functions independent on a set of independent and orthogonal random variables with no probabilistic densities. Stochastic calculations are used to improve the prediction quality of the applied fine simulations. However, a comparison of the variance of the calculation paired with calculation precision reveals a calculation error that is considerably larger than the calculation variance. Okay, so far we are talking about the definitions that were handled. In this article, we are going to speak about the results. We apply this model in the calculation of electrical models. It can be done reference to the uncertainty of magnetic deviations. In this context, third carry calculations, aspects such as the calculation of force machines, taking into account that these variables are independently on the occurrence of calculation magnetic field. In the results, if we observe the feature which corresponds to the normal distribution of the system, it can be deduced that it is probable that the permutation of the magnet which causes the lowest get torque also creates one of the lowest gear pairs in a discretization simulation dinner. Furthermore, the relationship between the gear or the permutations is expected to the whole. On the other hand, the feature shows the cumulative distribution of the two third results, showing the unacceptable stochastic predictions error that is committed when applying the coarse mesh for stochastic predictions. Okay. In conclusion, we can be seen that the use of stochastic models, such as that the Chaos polynomial and the Monte Carlo models, allow the improve to the predictions of an event. However, in many cases, when carrying out the simulation of uncertainty variables aren't taken into account, which generate that they find bases that cause the simulations to be invalid. For example, in this case, aspects such as the precision of the magnetic field and the flow space must be taken into account in the analysis of the torque. Are since these two factors have a direct impact on the system and can generate errors during the respective simulation. Finally, as we observe the final graph with time, we can show the degree of precision that using this method has with respect to the other method. In this case, a line serves where it is evident that the data obtained obey an uniform distribution and its line of strength resembles. Okay, this has been my presentation. I hope you like it. Thank you very much for your attention.